Good evening everyone. This is Harpreet as a maths teacher. Dear students, I hope you all are good and fine and completed the previous one work as we have started chapter number 12 of class 10th maths. That is as a area related to the circles. And we have completed already area of the sector and area of the segment. Today we will start the new topic, that is the areas of the combination of the plane figures. Mean to say we have given the some plane figure and some shaded part we have given, and we have to find out the area of them. So how to find out those shaded area? So let us start with the exercise 12.3 and then you easily come to know how to do this type of the question. So here from the first question we will start. It is given that here as a one circle having the diameter as points, end point as a QR. Here is a O as a center. Any another one point as a P. Here it is given. Then they are saying find out this one shaded area. And such that PR it is given. PR value it is given 7 centimeter. And PQ it is given. PQ it is given that 24 centimeter. We have to find out this shaded area. You can easily see whenever we have this one shaded area, it is the part of the semicircle, and from the semicircle area, if we will exclude this one part as a triangle area as PQR, then we can find out the shaded part area. Okay, so mean to say what we will do, area of shaded portion is equal to, we have find out the area of semicircle minus area of triangle PQR. So these two things we need to find out. Now to find out the area of the semicircle, we need the radius, that is the pi r square upon 2. So radius is needed, but the radius it is not given, and the area of the triangle PQR, two dimensions are given as a PR 7 centimeter and PQ is equal to 24 centimeter, this much. And to find out the area of the triangle, now let us see here, as QR is a diameter of the circle and the side of the circle, side of the triangle also, then we can see the P point lies inside in the semicircle. So this implies here will be definitely the right angle. As into the 9th class we studied, into the semicircle always the angle is 90 degree. Okay, so this triangle is right angle triangle. Then we can use the formula as 1/2 into base into height, where we have given the base is 7 centimeter, this much, and PQ as a height. Now to find out that this one we will use, it is the right angle triangle, then we can use the Pythagoras theorem also. Okay, then we can easily find out the QR, which is the diameter, and from the diameter we can find out the radius. Okay, so let us use it and to find out the area of the semicircle. Now here, as I am saying, here angle P is equal to 90 degree. We will write the reason. In semicircle, angle is always 90 degree. So this implies it is right angle. So this implies triangle RPQ is a right angled triangle. If it is a right angled triangle, then so by Pythagoras theorem, we can use the Pythagoras theorem, which is equal to QR square as a hypotenuse square is equal to PR square plus PQ square, perpendicular square plus base square. So QR we need to find out, which is equal to 7 square plus here is the 24 square. So 7 square is 49 plus 24 square is 576. So its sum is equal to 625. So we can find out QR is equal to plus minus square root of 625. So here is a square become on this one side square root, and it is the positive and negative. But we will take only the positive value because it is the diameter of the circle and it is always as a positive value. And it's a square root 625 is, we know that is 25. So we come to know QR is equal to 25 centimeters. So we can write here as a diameter is equal to 25. So this implies radius is 25 upon 2 as a centimeter. Okay, so we have now the radius of the circle. So let us do as a shaded area. Now shaded area, which is equal to as semicircle area as pi r square upon 2 and minus of 1 by 2 into base into height as a triangle area. Now let us do the calculation. 1 by 2 as a 22 upon 7 pi value. Radius is 25 upon 2 into 25 upon 2 and minus. This one is a semicircle and 1 by 2 base is 7 and height is 24. You can cut out here on the 12. So we left here as 2 is cut out 22 on the 11. So we have 11 into 25, 25, 6, 25 upon here is 7 2s are and 2s are 28 minus it makes us a 12 7s are 84. So we have now if we have to multiply any number by the 11. So these numbers are left number and right number as it is and middle number are the sum of the digits. So here is 7 and 8 upon 28. It is the multiplication by the 11 by the short formula 84 upon 1. Now we have to take the LCM by the 28. So here is 6875 minus 84 28s are. So it makes as a here is it is as 2352 and now go with the minus 5 minus 2 here is 3 2 5 and 4 upon 28 centimeter square. So this one is a shaded area of the given figure. Okay, so by this we can see whenever we have given the part shaded part, we have to see in the plane figures how can we confirm the shaded part area. So let us start another one question. Okay dear students, here we have the question number second. Two circles with the same center as a O, it is drawn, it is called as a concentric circles. As a central angle it is given 40 degree and then they are saying that this one shaded part we have to find out the area. If we will see, it is the, if we will see as a AOC is a sector of the outer circle and BOD is a sector of the inner one circle, right? And we have given the two circles as a smaller one circle, radius is 7 centimeter and bigger one circle, its radius is 14 centimeter. If we will write here as OB which is equal to the radius of the smaller one as a 7 centimeter which is small r I am denoting and OA which is equal to as a outer circle radius I am denoting by the capital R which is equal to 14 centimeter. Okay, to find out the shaded area from the sector area outer one and we will remove the sector area of the inner circle, then that is the shaded part area. So we will write here shaded area is equal to area of sector AOC, okay, sector this one, and then minus area of sector BOD, that is BOD, this one. Now what is the sector area formula? That is theta upon 360 multiplied by pi r square. Now theta is already confirmed. So here where I am writing theta, already it is same, theta upon 360 into pi outer sector, so that's why capital R, and theta upon 360 it is same into pi inner circle, that is small r as we have denoted here. So we can take the theta upon 360 into pi common, so it left as a r square minus r square. We can use the identity here as a square minus b square. So we will write here theta upon 360 into pi into r plus r and r minus r. Remaining are the values as you will fill and do the calculation. 40 upon 360 into 22 upon 7 r plus r, mean to say 14 plus 7, it makes as a 21, r minus r, 14 minus 7, it makes as a 7. So it cut out here on the 9, here will be 7 and 7 cut out, 9 and 21 will cut out on the 3 table, 3s are and here is 7s are. So left over here 22 multiplied by 7, it makes as a 154, denominator into 3 into the centimeter square, this is the shaded part area. Okay, let us see one more example. As a question number 3rd, here we have given a square. ABCD is a square with the 2 semicircles are cut off and remaining shaded area we have to find out. Then what we will do? Here we will write here as a shaded part area. Shaded area is equal to, if we will take out the full area and we will remove these 2 area, exclude these 2 semicircles area, then remaining part are the shaded area. Okay, so we will write here area of square minus 2 times as a area of semicircle. Both semicircle have the diameter same as a side of the square is same always. It is 14 and it is also 14. So that's why I am writing here the 2 times semicircle area. So which is equal to square area is side multiplied by side into 2 times the semicircle area pi r square upon 2. Okay. So side is 14 into 14 minus 2 and 2 will be cut out. So 22 upon 7, radius is left as a 7 into 7, right? As a 14 as a diameter. So radius is 7, 7 and 7 cut out. Then 14 14s are 196 minus 22 7s are 154. So this one shaded area we left over here as a 2 and 4, 42 centimeter square, and this one is a answer of the question. Okay, like as this, many questions are related to the 12.3 exercise. If you will try, then you can get the answer by taking this one as an example. And if you have any query, then you can ask me into the Zoom session. Thank you and have a nice day.